But with this additional mineral, that will not happen. And so the ability goes up. And so what you said about
hello everyone. Back again with Demi here and Marcel, and of course me, for another interesting topic that will be brought by Demi. So Demi, what is the topic that you will share with us today?
Today I will introduce a topic from one of my friends and partners from Holland, DK Support, Dion Kok, who's used to be my former boss and now a partner who I work with. And in our adventures in 2010 to 2012 in Holland, we were busy with a few projects, and then we discovered that some of the big companies in the world built their oil plants really fast, a few square kilometer in 2-3 months, and we were really amazed how they did that, because we also knew that this was about heavy-duty pavement. So we investigated, and then we found out that there are a few products in the world available that are similar. To tell a little bit of history, officially it's a Japanese invention from hundreds of years ago, I think 150 years ago, and they used it to build the Panama Canal. If you go to the Panama Canal, you have these big walls, right? And from that day on till now, I think they're over 100 years, maybe even 150 years old. These are indestructible, and they use this mineral for that. And then some of the companies in Europe started to replicate it and try to find the original formula. And there are, I think, 7 companies in the world who are supplying this. And we found out that one of the suppliers in Belgium had actually the highest quality of mineral for this way of creating pavement that you can also use for road building, but also for the airport when you have a soft soil. Sometimes when you have airports, for example, in Kalimantan, you have a lot of soft clay. And the unique character of this pavement is that you mix it with the soil, and therefore it also have the same MPa, that's around 10, and that means that normally the road sinks into the soil, and because it's too heavy, because of all this concrete and the armored steel, and this road actually floats on the soil, and therefore never sinks. And because of the ingredients, if you talk about roads that are built close to the road, to the sea, then the salt water always damages the cement very fast, and then corrosion also happens really fast, especially when you use armored steel. And with this road, it doesn't matter, because it's already minerals with salt in it, so it actually doesn't affect the quality of the road, and will also not affect the endurance. So that's what I want to show today, Randy.
Okay, I heard about that product, and it sounds very interesting. I believe that it can bring us a breakthrough in such a sustainable product for our infrastructure work. So please, Demi, you can start the presentation that you want to share with us.
Okay, let's go there. Soil concrete. We say that in very simple words, that is faster, stronger, and cheaper as other roads and foundations or pavements. I will make it and explain it very shortly. I will no longer do the history because we already did that. This road and pavement builder is actually still unwanted, unwished actually. Because why? Because it's faster, because it's cheaper. So for the bigger road companies, profit-wise, not interesting. But for expanding infrastructures like in Indonesia, it's very interesting. I mean, I've been a lot to the design company here in Indonesia, and there are a lot of roads that need a lot of attention, and most of the times it takes years, weeks, months, years to repair these roads with pus in it, and that's why this will be an addition, and I will explain a little bit why. So why would you use Geosta? If you compare it with a normal road from 1 kilometer long and 7.5 kilometer wide, then you would need around 113 trucks to transport all the material. You need around 2,560 tons of new material. You have around waste material 1,300 tons. You need diesel 7,000. You need construction time will be around 20 days, and you have a CO2 footprint of 3,177 per ton. And then when you use it with Geosta to build the same, you only need 8 trucks. You only need 168 tons of new material. You have no waste at all, maybe some rocks that you don't want in the soil. You need only, based on those trucks, 1,100 liters of diesel, and the construction time of 1 kilometer will be 3 days, depending on what kind of equipment you use. I will show that later in the video with videos. 1 kilometer, 7.5 meter wide would be with high-tech equipment from a company like Waskita, probably 1 or 2 days. When you do it low-tech in Kampung on a forest road, then probably it will be 5 to 7 days. And the CO2 footprint will be 25% what it was. And because of the speed, you will also probably have a cost saving around 20 to 30% on the common cost. And this is already proven. Many people always ask me, do you have proof of this? Yes. Do I have samples? Yes, but they're in Brazil, they are in Japan, they are in Switzerland, they are in Germany, they are in Holland for bicycle roads, and I have more than 80 quality certificates from all kinds of institutes, quality institutes, universities, and other like SNE, other companies that have good inspection for materials. And for example, the Volkswagen fabric in Germany is built on this. In Switzerland, they use it for the roads, and in Holland, we only use it for the bicycle road till now, but just because we're also still proving it there. And also, we use it in the pavement for the harbor in Rotterdam for a few pilot projects already. So, what is it? What is this Geosta? Geosta is a brand name, of course. The DK support is working closely with them, and therefore, Cisnesia or we in Indonesia have access to this via DK support. If someone from Indonesia would order DK support Geosta themselves in Belgium, probably they will here go to DK support or go to Demi, because we are very close with each other. Geosta is like a white powder product that is in combination with the local soil and cement and water that will form that it will actually turn almost any soil type. I think it binds 95% of the soil depending on the silica level into solid concrete of high quality, strength, and 100% environmental friendly. So the pH is 0 after it dried out. And that is without armored steel. And that's most important. Also for the cement, you need one of the higher quality cement, but that's just to ensure the quality of it. So besides the optimization of the binding process, Geosta promotes long-lasting the strength development of the Geosta Soilconcrete construction. And the testing of this development will be 7 days, 14 days, 28 days, 56 days, and 91 days, like any other normal road. You'll also test in the same way. Simply go there, we make a little piece on the side, and then we drill a piece, and then we do a strength test. And then to show that in a little, how do you call that? It optimizes soil for binding with cement. You have to imagine that there's a microscopic strings growing till a certain length of 42 centimeter, and they will bind together, and therefore you create the armor actually, a synthetic armor by mineral binding. And every soil is more or less charged with organic particles, what makes the binding with the cement possible. They really grow during the 91 days. Actually, if you would take a road and you build it now, and you go back there 5 years later, then the road probably will be stronger than when you left it, because it keeps on strengthening themselves. And by elimination of the organic pollution, meaning that if you would use polluted soil, then the mineral will neutralize it. And also if you build on polluted ground, then the pollution cannot go through the ground. And so the pollution stays where it is. And for example, also when you have vegetation, what you normally see in the forest road, the roots cannot crack the road. Uncrackable for that. It's a high binding of the cement and existing soil particles. So this is measurable and leads to almost fluid penetration for resistant construction. The difference between Geosta mixture with cement and other concrete is that this has to be moisty the whole time. It has to have a minimum, while you're constructing it, it has to be a minimum 20% moisture. So that means when it's raining and you're building the road, you cannot stop, you have to continue. And this actually grows with water. And what it explains, the construction for the three-dimensional long crystalline connections. I have a picture actually for that, but I'm not allowed to show that one because there's more information on it. So I have to explain. Like I said, the crystallines grow to each other and then connect and do. The armored steel also do the same, right? It connects all the concrete together and the stones, and then makes it into solid brick by the measurement of the cable. How do you call that? The iron elements, right? And the crystalline do itself into the concrete. And so it's static and dynamic. If you say that in summarized, this way it's very durable, maintenance-free, frost and thaw resistance, so drought. Fixation of chemical pollution directly after execution, high bearing capacity. Meaning that normally when you build a concrete road, you cannot use it after 28 days, you have to dry it first. This road can be used after 7 days. So that's pretty fast. Actually, already right behind it, but that sometimes damages the quality. The excavation of the ground soil is not needed. Nearly every type of soil material is usable. What you sometimes do here in Indonesia is you have the old road, and then we build a new road on it, new layer. It's also possible with this, but then you have to bring the sand or the soil that you need. And the building cost and building time is saving high pressure and bend pooling strength. And so meaning that the quality is higher, maintenance free almost, and the reduction of the top layer asphalt and multiple possibilities. Meaning normally you have to put a thick layer of asphalt on it. This will probably already is enough if you just put a little bit tar. And if you really want to use asphalt, only a few millimeter. And so it lowers the use of materials in general, in May. And then just a simple comparison, the strength test is that it's around 30% more stronger, or let's say, than normal sand with cement, the normal concrete, right? Especially after 91 days. As you see that, what you also see a little bit, if you would take a longer one, then you see that the cement slowly lowers. And the Geosta keeps increasing. The longer the older the road is, the stronger it will become. And with cement, it's the opposite because of the water draining out. Right, so the binding becomes less, and then inside it becomes sand again. Right. So, how to prepare a project? So, okay. So, how do you prepare a project? Preliminary analysis. Very simple. You create a representable sample by taking 25 kilo of the soil where you want to build the road. You bring it to a company like Indo, and there you will create the right mixture with the soil of mineral, how many you need, and how many cement you need to achieve the right strength, right? And then that's the strength, the moduli, the pooling strength, etc. And with this lab test, we can teach any company how to make the constructive calculations, because it's actually really simple. For example, in general, the normal soil type would probably need around 300 to 400 gram of the mineral, with around 50 kilo of the cement per square meter. And that's it, and water. But it's actually pretty cheap, right? So how do you build that? It's very simple. I will show stepwise how do you prepare the road and how do you construct it till it's done. And that's why it's really simple. Also for people in the kampong, it's really simple to understand. The first what you do is you take away all the obstacles like trees, plants, grass, and rocks. And when I say rocks, I mean rocks bigger than 2-3 centimeters. You take them out, right? And what you also can do is you put in the, how do you call that? The thickness of the road that you want in soil that you bring yourself, is also possible, right? And then you will prepare the deepness. You cut it in the right deepness, like in normal roads. It's normally 30 centimeters to 35 centimeters in Holland, for example, for light vehicles, 10 tons per square meter. And then you cut it on 10 centimeter deep, and then you bring the mineral in. You simply mix it with the topsoil. And while you're doing that, you will apply the spreading of cement. Then you mix the cement and the soil into the right depth, 10 centimeter, 20, 30, how thick you want it. And then while you do that, you spray it with water. Very, very important. So before, during, and after the execution, at least 20% moisture level. And then you compact it, and that's the secret. This mineral grows on compaction. I'll show later. And then you create it in the right profile, so the road is exactly how you want it, and as wide as you want it. And then you compact and you finish the work with, for example, eagleizing with a butterfly, how we call that. And that's how simple it is. No, you don't need any, how do you call that? Armored steel. You don't need 10 layers of different kind of gravel and stones to make the road better. It's only this. And then I will show you, because seeing is understanding, right? So the machines that you need if you want to do it professionally, it will be a Geosta spreader or a spreader. You see, this is a simple thing, where you can measure how many mineral you need for per square meter. You will need a cement spreader. Can be low tech, high tech. You need a mixer that mixes everything together. You need a compactor to push the soil in, and you need a grader for the lining of the road. And you need a water dispenser to make sure that it's wet, and you need also a finisher to make sure that it's very eagleized. But of course, I know we're in Indonesia, and I already got a lot of feedback on that. But yeah, we have different types of soil and different kind of building. So let's show you how to do this in a forest road. So imagine that we are in the kampung. Does cranes, and Mammoet worked together with Geosta, and they created they call it the Mammoet, and made it into their own brand. And what they do with that, they will explain in this video. And if you were impressed by the 6,000 square meter in one day, this will impress you more. In Holland, there's a company that's called Mammoet, and Mammoet sells cranes.
We live in a world of big. In heavy industries, the quest for economies of scale leads to larger plants, bigger vessels, and heavier components. Nowhere is this more visible than on site, where construction activities require greater load-bearing capacity on the ground. Stabilizing and fortifying soil typically involves transporting gravel, wooden mats, concrete slabs, and other materials to and from the site. This is not only cumbersome and time-consuming, it also drives up both a project's costs and its carbon footprint. To tackle these challenges, Mammoet has created a better way to increase load-bearing capacity on the ground. It's called Enviromat. More efficient, more cost-effective, and more sustainable, Enviromat is a local solution to a global problem. By using native soil, Enviromat makes it possible to build a strong and flexible mat on site, rather than transporting it in. An easy-to-install layer that increases load-bearing capacity up to 50 tons per square meter and beyond. Water and frost resistant, Enviromat has been successfully tested on different surfaces in various climates around the world. In many circumstances, it has proven to be a more reliable and safer alternative than conventional reinforcement methods. Designed to stand the test of time, Enviromat is durable enough to remain in place for decades, or be crushed and reintegrated into the native soil with no environmental impact. Mammoet's Enviromat offers an efficient and sustainable option for a wide range of ground applications. Temporary roads, assembly areas, and hard stands. Enviromat unlocks new possibilities for saving time and money. Yet another way Mammoet is paving the way for greater project efficiency. Mammoet, the biggest thing we move is time.
So the next video will be an Indonesian company that do the same here. Well, let's go. So thank you for watching. Randy, I think you have a lot of questions for me. So this was a short presentation, but I cannot tell it better than the videos.
It's very impressive. And I think that a lot of people forget that we're talking about sustainability. It's not always about buildings or certain products, but we start from the basic, which is infrastructure, and roads are something that is quite dominant in. We're talking about infrastructure, yeah, roads, railways, and I think that if you start from doing some sort of sustainable approach with build roads, I think it's very a good approach toward a more sustainable development, especially in areas that still have a lot of roads that need to be built. And in Indonesia, there are a lot of places that require such thing. I think this kind of technology can bring new insight. If talking about in Eastern Indonesia, or not even Eastern Indonesia, but certain places in Sumatra and Kalimantan, a lot of road works need to be done, because like that linking from one point to another point is basic if you're talking about economic spread, and it's basic if you're talking about how we can make a good spreading of economic and development in this country. I think it's very good, and I really hope that this kind of technology can be implemented in roads development in Indonesia.
Accessibility is the key to improving the social economy and the spreading of new business.
Yeah.
Totally true.
Yeah. Without roads, economy will be only centralized in certain area, and it won't be we will not be like spread all through this country. We can do approach with this technology, and one thing that comes to my mind is how we can implement this technology, especially in areas that has extreme conditions, like hills and very remote area, which totally the access for
there are different solutions for
materials is not established there. So yeah.
If you want to go to the high rises and if you want to go to the mountains, there are a lot of technologies available with hybrid steel and reinforced fiber plastic that are lightweighted, stronger than concrete, and more durable, and also lower maintenance. So that would be more because in the hills and the mountains you need a lot of how do you call that? Bridging, right? And therefore you can better use those kind of structures. And of course, on the layers you can use this. If there's no soil, you can bring the soil.
Yeah, because the material mobilization to the site is very key. And it's first regarding the cost, the construction cost. Obviously, we can lower down the cost. We can do savings and put the budget to another thing that's probably more significant. And the other thing is, if you're talking about sustainability, then reducing mobility costs or mobility effort, it means we can lower the carbon footprint for that project.
Yeah, but with this additional mineral, that will not happen. And so the ability goes up. And so what you said about going to the remote areas and see how we can do that there. If you need less materials, then you also need less stoppers if it's in the high mountains, for example, right? Because you only need the mineral and you need cement. That's what you need to bring there. And it's easier to transport all the armored steel, the caskets for the road building if you talk about highways. And so, and of course, what's also important is that there has to be a mixture factory here of the soil, concrete and mineral.
Yeah, and the other thing that is also shown from your video is about the how speed it is, what the speed, how long and how many roads that we can achieve in a single day, how many meters. Yeah, and obviously the speed is also the key. So let's say in 1 year, if we can do 200% or 300% of the normal conventional technology, that would be great to fasten the economic development, social economic development across the country.
Only then you have the same problem that we have in Europe. The reason that in Europe we cannot really push this through. So we have some smart companies who want to be sustainable, who use this, like for example Volkswagen. The whole industry area is from this, and here and there we have some roads. But that's because most of the road builders live on maintenance, right? And this is actually maintenance free.
What do you think about it? Can we do some customization?
Yes, we can do that. We can. It's very simple. Like I said before in the presentation, you can when you do the strength test, you can actually decide how much of the mineral you add into the soil per square meter, and that the amount of mineral you put in will decide. The amount of mineral that you put in will decide how strong the bearing capacity is. So if you, for example, want to build a small road for light vehicles from 10 tons per square meter, for example, then the road has to be 35 centimeter thick. And I dare to say that then you need 300 and something gram of the mineral per square meter. And like I said before, 50 kilo of cement, and that's the bearing capacity. But if you want to have a heavy duty with 100 tons per square meter because you want to use it for a track on the airport where a big Boeing can land, then probably will use around 1 kilo per square meter. And then it will be probably 50 centimeter to 1 meter thick. Right, so yes, specify that based on the requirements. So if the client would say we want a bearing capacity of this, then it's a very simple thing of lab testing.
Yeah, that's great.
You go to the lab, you go to the super window, you take the mineral, you take the soil, cement, you mix it, you make a mall, and then you drill it, and then you get the tank test, and then and it takes a week or 2 weeks. So that's not the challenge. So I think it's possible. And talking about cheaper or expensive. I remember I had a proposal asked for a certain area in Jakarta port 2, I believe, and there was a road constructor that built a normal road, like vehicle road, for 35 centimeters thick, and they asked me to calculate a road. So that was the first time in my life I engineered a road with this, because they Geosta support teach me how. And the conclusion that I made was that the common price per square meter in Indonesia for a light vehicle road is around 1.5 million rupiah per square meter, including the asphalt. And then I don't want to say the price because it's really cheap. Let's say it was 20 to 30% cheaper, but actually it was more than up to 50.
Yeah, that's interesting. Marcel, what do you think?
About the Eastern Road, I think it's very interesting to speed up the construction of the street or the road. It's just the cement mixed with the chemical, minerals, and the soil itself, and became a road. Just like that. So the soil is mixed by the cement too.
Yep. The soil is already there, and if there's no soil, you bring it with you.
Yeah, that's
so also it doesn't need stone, small stone, or we call it split. But to critical,
you have to take them out before you start constructing. So Marcel, what you say is really as simple as you saw it. It's also how simple that it is, right? And if you want to do adaptation, for example, maybe like what we talked about last week, water management. Maybe you want to make it more into water management. Then you can put in a frame on the side, and the water can go under the road, and with the car track on the upside down car track. And then you can actually also transport the load under, and it will be sustainable. And also the example that I showed you last week with the underground channel, on the Maas Boulevard, where you saw the channel where they collect the water on the ground, under the parking garage, is built with the same mineral.